Hello there. Yeah, so I'm Max Kreminski. I'm talking about making better nonsense through computers. And before we get into this question of what is better nonsense, we kind of need to think about what nonsense is and what makes it good in the first place. There's been this long tradition of artists in the English literary tradition engaging with nonsense in various ways, so clearly they find something valuable about it. There's this famous nonsense poem called Jabberwocky by Lewis Carroll that kind of uses a bunch of made-up words and swaps them in where you'd expect normal English words to go to create the sense of a very otherworldly environment that might be hard to get across otherwise. There are attempts by Italian singers to create songs that give the impression of having English spoken to you when you don't actually understand English. The song was quite popular in Europe for a while. And there are even computational attempts to generate nonsense. I personally like the King James Programming Tumbler, which is sort of a mashup via Markov chains of a bunch of foundational programming texts and the King James Bible, which produces these aphorisms that often don't make much sense in a semantic sense, but then often have sort of the ring of truth and almost this biblical air about them. And so I really like all of these sort of nonsense explorations. Now, I think one thing that these nonsense things have in common is that they help us see things differently, to use language in ways we wouldn't expect, to kind of come into the space of meaning from an alternative direction, maybe going in through the window instead of the door, as it were, and help us get outside of the ways that we normally express ideas towards something that's different and new. And computers have this long history of being used in nonsense production because they're often not good at making sense. In many ways, the history of natural language generation is a history of attempts to get computers to finally make sense instead of nonsense. And now that we've kind of succeeded at this with ChatGPT and so on in the last couple of years, people are already starting to wax nostalgic for the era where language models were not quite so good at making sense and were in fact a little bit better at nonsense instead. And so in terms of whether computers have gotten worse at nonsense in the human sort of creative ecosystem input generation context, we actually were able to do a little study on this. We compared people who were using ChatGPT to help them with ideation versus people who were using the Oblique Strategies deck, which is just a deck of cards that Brian Eno made where you pull out a card and it says a weird phrase and you do what's on the card. And we found that ChatGPT actually causes people to come up who are different people with more similar ideas to one another. So it causes this homogenization effect and is not really helping people get outside of their predefined ways of thinking about things in the way that we would hope that good nonsense really would. And so now that we know that we need computers to generate good nonsense and that we know that they're getting worse at generating nonsense, I decided to investigate via these 3 small computational prototype projects how we can get good nonsense back into the output of computational systems and what it would even mean to achieve that reliably. So first of these projects is one called Blabrecs, and this is a mod to a game called Scrabble that some of you might know. It's a game of sort of taking letter tiles out of a bag and assembling them into words to score points. Now, the normal thing that you do in Scrabble is you play English words, but in Blabrecs you can't do that. You're not allowed to play anything that's in the actual English dictionary. So arbiter, like that's out, you can't play it. In addition, we also want to make sure you can't just like key smash or put totally random sequences in there. So like Zamksh, that's not pronounceable. You're not allowed to play that either. But what you can play is things that sound English-like, such as the word Grenkistry, which is pretty obviously a word and it looks good to me, so we can play that one. And Grenkistry is an example of a word that basically a classifier trained on the English dictionary misclassifies as English, even though it is in fact a nonsense word. So this classifier has kind of been given a bunch of examples of dictionary words, and sometimes it gets a little bit overzealous and says things that aren't actually English are English, and those are the ones you're allowed to play. We have 2 different versions of this. One of them is a simple Markov chain-based thing that looks at trigrams or 3-letter sequences and just kind of multiplies together the probabilities of each individual trigram to get a score for the word overall. And this classifier actually is looking for words that are more likely than at least half of the English dictionary words of the same length, according to its learned rules. So when you play a Blabrecs word using this classifier, you're playing a nonsense word that is more probable than some actual English, which I think is kind of beautiful. We also trained an alternative classifier that's based on a convolutional neural network. And this one is using sort of training data that's positive examples from the dictionary and negative examples that are sort of generated with the same letter frequencies as English to make sure that it's learning like good generalizable rules for what constitutes a real versus a fake word. And so you can kind of play these off against one another. They have slightly different textures and slightly different quirks. And sometimes they misclassify a word from one's perspective. The other one is like, yeah, that's good. The one's like, no. And so this is sort of a model that helps us to produce better nonsense ourselves as people via sort of like imposing a constraint on the creative process. Now, you can sort of generalize this further and use this exact same model to produce what I call Blabwreckage, which is sort of a single operation that both wrecks and repairs text. So here we have an instance of pasting in a poem that was created by, like a well-known poet. This is Ozymandias, it's a famous poem. And we can see here that it starts out like, I met a traveler from an antique land who said 2 vast and trunkless legs of stone stand in the desert. It's a poem about like destruction and impermanence and that kind of thing. But what happens is when we sort of go over this sequence of words and repeatedly select single character edits to each word that most improve that word's likelihood according to the Blabrecs dictionary probability scoring thing, we end up mutating the text gradually into pronounceable nonsense that's kind of in the Blabrecs English. So we end up with something that sounds kind of like I zessa gravelis pronal unlik nons, zes fors predistance gracklers versus chons and trivivers, which is very pronounceable, has a lot of interesting evocative sort of sounds in it, I think. We get Ozymantes zinges zines, who I think would fit in well at Bang Bang Con as a character in this poem. And I think this is a really interesting way of getting outside the usual ways of taking English texts and reading them to kind of read them in a more nonsensical way. We can also do something really interesting where we generate total nonsense, i.e. random noise that just is rendered as characters here, not even with English letter frequencies, just completely like sort of summoned from the ether, and turn this via the exact same process into the same kind of pronounceable nonsense. So here we have like bleeds, zivers, overchan, kaiwaring, zes non-sesaman, gradist, and kelar. And you can sort of keep on reading this. We get words like quotypermatic and calyx, which both sound like sort of keyboard-related words to me, maybe technical terms that we could apply to some of the talks that have been given here. And so I think this is really interesting that the same process both takes recognizable English and turns it into nonsense, but also takes noise and kind of repairs it into closer to English nonsense in a way that is very interesting. I actually use this to make some generative Christmas carols for a friend's generative advent calendar. So we take Jingle Bells and turn it into Zingly Billy, for instance. And most recently last night, I was hacking on this thing where instead of just using the dictionary-based model that Blabrecs is using, I can also train these on arbitrary input texts. So here we have a version of Ozymandias that begins, I yet a warver from an antique man, the gain, the west, and cruckless yes of Vyong stand in the Navir. And this is actually a style transfer from Moby Dick. So this is the kind of thing you might imagine Ahab saying as he's like standing there in the sea foam spearing at the whale. And I think that comes through really well in this instance. Okay, so getting away from this dictionary mangling sort of thing, what if we move instead towards the mangling of sentences and sort of semantic meaning via what we call sentence embeddings, which are a kind of thing that we take a sentence that's been sort of like written out and turn it via a process of sort of proximity matching to a mathematical vector of numbers that just exists in this very large high-dimensional space. And proximity in this space essentially means similarity in semantic meaning in some weird sort of roundabout way. What we can do in this case, this is sort of a collaboration with a friend of mine, Barrett Anderson, is take an initial input text. In this case, at the top, we have what isn't saved will be lost. This is the title of a poem by another friend of ours. And again, look at all possible one-character deletions or erasures of this input text and accept the one or perform the one that is retaining most of the meaning in the input according to this sort of semantic distance. So in this case, we end up deleting the last sort of parenthesis on the end there. That doesn't really add that much to the interpretation of the sentence. And we preserve most of the meaning through this single character deletion. Then we do it over and over and over again, kind of winnowing down this sentence to like the essence of its meaning at the very end. And we end up with something that's like Savelost, which is the name of the system, actually. The same system sort of named itself. And you get this kind of progressive compression of the sentence into a smaller and smaller unit of language, which is further and further from how humans usually use language, but in some ways like trying to get at the heart of what it's trying to say. And what's interesting is that it also has sort of a tragic dimension because the system cannot look ahead into the future and see that important words like isn't might be really useful for preserving the meaning of the sentence later on. So it tends to ablate them relatively early when there's a lot of redundancy in the sentence, and then have to kind of come up with suboptimal ways of saying the same thing later on when it can't use that negation anymore. So this, I think, is a really interesting instance of what Alison Parrish, another computational poet, would call a semantic space probe. She describes space probes as things that go into hostile environments for us, places where we can't survive as humans, and sort of report back data that we might sort of find interesting or useful. And similarly, semantic space probes go into these hostile semantic spaces of nonsense, which you don't want to spend much time looking at as a human in sort of an unfiltered way, and kind of report back their findings to us. So this particular space probe gets kind of more and more lost in semantic space as it drifts, and I think there's something kind of beautiful about that. Okay, so what have we learned? Number one, I think, is that you can generate good nonsense by relaxing some constraints on how you express ideas while retaining others in unexpected combinations or ways. In Blabrecs, we see this where we kind of retain the constraint that you need to say things that sound like English while relaxing the constraint that you need to use actual English words that are known in the dictionary. With Blabwreckage, you kind of see the same thing applying where we're indexing into that same space of nonsense from different directions. So it's not just a human selecting letter tiles from a bag of Scrabble tiles and trying to make words out of that. It's various other sort of sources of noise and sources of like unstable input that can help to drive this system in unexpected directions. And in Savelost, of course, we have this interesting thing where we relax all the syntactic constraints gradually on this word. And so the sentence kind of like info-theoretically melts while retaining some of its semantic meaning, sort of staying anchored to that initial meaning vector that it was trying to compute. And more generally, I think nonsense kind of works as the antidote to cliche in a lot of these contexts. We live right now in a world where cliche is very, I think, dominant. And cliche is the way that we try to make meaning, try to make sense when there's not a lot of reliable ways to make sense. We tend to fall back on stock phrases, on known idioms, on ways of saying things that are considered to be good or reliable, and kind of retreat from things that might be misinterpreted or misunderstood. And things like ChatGPT kind of mechanize cliche in this very powerful way, so that they're good at making sense, but bad at saying anything. And so I think there's this really interesting thing where nonsense being the antidote to cliche means that we need to kind of value nonsense, bring it back into computation, and find ways to sort of reintroduce nonsense into our creative practices as an input. Okay, so all this stuff is playable. Here's a bunch of links. I'll put these in the Discord chat afterwards. And I am very findable on the internet. Okay, thank you.